Hi, my name is Vincent, and today I want to show you all how to solve rational inequalities. We have 3 examples here that will increase in difficulty as we go. But for the first one, we're starting off with this inequality here. X over 4 is greater than x over 2 plus 6. So for ones like this, when there's only x's in the numerator and nothing in the denominator, we could solve these kind of straightforward, which means we get all the x terms to one side, and we put all the numbers on the other side. So here, if we subtract x over 2 on both sides, x over 2 cancels, and we've got x over 4 minus, and instead of calling this x over 2, we'll note that I could rewrite this as 2x over 4 if I multiply top and bottom by 2. So I could say minus 2x over 4, and this is greater than 6. That's all that's left. So now we'll get this out of the way. Don't need this. So then to simplify, 1x over 4 minus 2x over 4 is negative x over 4. And this is, make that a little neater, so negative x over 4 is greater than 6. So then all we have to do to solve is multiply both sides by negative 4. The two negatives will cancel on the left, and then the 4 over 4 will cancel, leaving us with just x. But just be careful. Anytime you multiply or divide an inequality by a negative on both sides, the inequality symbol has to switch directions. So we're going to go from greater than to less than. And we'll have negative 24 here. So our solution to the first question is we have the inequality x is less than negative 24. So our solution is x is less than negative 24. We could write our answer like this, or we could write our answer as all the numbers from negative infinity to negative 24. So both of these are acceptable depending on what form you have to write your answer in. Now, in order to check our solution, we could use the calculator. I've already typed these in ahead of time, and these are for the other questions, but x over 4 is what I have on the left, and x over 2 plus 6 is what I have on the right. So I could also check by plugging in test values from each interval, but that's going to be how we're going to actually solve the other ones. And since we're focused on what's happening at negative 24, I'll make my smallest x value negative 30. And we're going to see here why this shows that this solution is valid. So what we're getting at here is this was the graph in blue, x over 4. That was the first thing we looked at. X over 4 was the one on the left. X over 2 plus 6 was the one on the right. And what does it mean for the graph of x over 4 to be greater than the graph of x over 2 plus 6? That means that the graph in blue is going to be above the graph in red. And you see how in this section of the graph here, the blue is above the red. And then the roles reverse at negative 24. This is the value negative 24. And then x over 4 is no longer greater. Now it's underneath. So for all values of x less than negative 24, the blue graph is above and the red graph is underneath. So that should confirm that our answer is in fact correct. Now for the second question, things get a little bit more involved here. So the method I like to use for this is I start off with a number line. And I first look for where is the rational expression undefined. And to find out where a rational expression is undefined, just look for where the denominator is equal to 0. So we have here that y cannot equal 0. So what we could do is we mark off the graph here at 0, and we're going to just go ahead and put an open circle, because that value is not allowed in our solution set, because that would make these two fractions undefined. The next thing I like to do is I look for the roots. So to find the roots, just set up the equation 5 minus 7 over y equals 2 plus 5 over y. So treat this as if it's an equation. And now what we do is we add 7 over y to both sides, and we could subtract 2 on both sides. So now here, these respective terms cancel, and we've got 3 equals 12 divided by y. Well, then at this step, you could do the cross multiplying, like, do some algebra, but just think 12 divided by blank equals 3. That means y has to equal 4. So y equals 4 is one of our roots. So if I want to make this number line, maybe I'll redo it and make it a little bit neater, since now I know the other value that's significant, is we could label 0 as one of our undefined values with an open circle, and 4 we could go ahead and color in. Okay, so this is one of our roots. So then we have 3 intervals to check. We have y is less than 0, we have y is between 0 and 4, and we have the y greater than 4 interval to check. And what I mean by check is we're going to pick test values to plug in here to see how they work out. So I know this is not necessarily drawn to scale, but let's say for the first one I try out y equals -10. This is the easiest value I could think of to use without a calculator. We would get 5 minus 7 over -10 is less than or equal to 2 plus 5 over -10. The concept that I'm using here is that any test value on each interval, if it's true for the inequality, then it's true for the entire interval. So then here, this works out to 5 plus 7 over 10 is 0.7. And we have to see if that's less than or equal to, and we got 2 plus 5 over -10, which becomes 2 minus 0.5. Okay, so all we're doing is testing out this first interval here. Now we've got 5.7 is less than or equal to 1.5, which is a false statement. So since this is false, this is not true. That means this is not a solution, so this interval is not part of our answer. Now the next one we test is this interval here. An easy value to check is y equals 1. So if you plug in y equals 1, we get 5 minus 7 is less than or equal to 2 plus 5. -2 is definitely less than or equal to 7. So since this one is true, that means our solution includes every value between 0 and 4. So the last interval to check is the y greater than 4, and we could use y equals 10. So that way we could write it in decimal form. And now here we got 5 minus 7 over 10 is 0.7. And then is that less than or equal to 2 plus 5 over 10, which is 0.5. And if we do the subtraction here, you get 4.3 is less than or equal to 2.5, which is another statement here that's not true. Okay, so since this is not true, just in case this isn't visible for you, I'll just drag this up. So since this is not true, that means this interval is out of the mix. So now for this type of question, because it was less than or equal to, we have to be really careful how we write our solution. So our solution here, if we want to write it out, maybe we'll just write it in green here so that it matches what we wrote above. Our solution is going to be 0 is less than y is less than or equal to positive 4. Okay, we're including 4 in the mix because 4 was a root, and we said that the inequality could be less than or equal to. So at y equals 4, the left side and right side are equal, and it's colored in here. So we're including 4 but excluding 0 because that's where the rational expression was undefined. Okay, an alternative way of writing our answer would be 0, 4 and put a bracket around 4 since we're including it. So that's just the second way of writing our answer, but this is sufficient down here. Now for the check, a little feature of these calculators, if this is the one you're using, you could hit enter on the equal signs and it tells the calculator not to graph the first two. And now we'll go ahead and graph the second two because that's for this question. And now we need the first one, the graph in black, to be underneath the graph that's going to come up in pink because it's less than or equal to. So we'll notice here it should happen between 0 and 4. So if we look here, and I'll go ahead and press zoom 6 so that it goes back to normal. So we'll see in a moment. Okay, so I'm going to press zoom 6 so that it goes back to normal because from 0 to 4 is what we're interested in the most. And we said we need the graph that's in black to be underneath the graph that's in purple. And notice from 0 to 4, that's the only part of the graph where the graph that's in black is underneath the graph that's pink. After 4, the black graph goes over the pink, and before 0, the black graph is above the pink graph. So this solution does check out based on our graph. Now for the last question here, we have a slightly more complicated one, just because maybe the algebra is going to be a bit trickier. But all we got to do here is we look for the undefined values. So the inequality is undefined at w equals -1 because we have a 0 denominator. So that's something that's going to be significant. And then the roots we could find by setting up the equation 3 minus 9 over w plus 1 is equal to 5 minus 1 over w plus 1. So since these rational expressions have equal denominators, we'll just go ahead and add 9 over w plus 1 to both sides. Sorry if I said the wrong variable before. It's changing up the variables just to make the questions a little bit different. All right, so 5 minus 5 cancels, these two cancel, and you've got -2 equals, and now 9 minus 1 is 8, so we got 8 over w plus 1. Now you could do a bunch of algebra here, but just think, 8 divided by, like what I'm thinking of is like 8 divided by blank equals -2, and then the blank is -4. So I just set the denominator w plus 1 equal to -4, and that tells me my root is w equals -5. Okay, so this is like a little shortcut. Since we already found the undefined value, we don't have to make it too crazy for ourselves. Okay, so then what we do with this is we take -5 and it's a root, so we color it in. And the undefined value of w, -1, we're going to leave open like this. So now we've got 3 intervals to look at. We got w less than -5. We got -5 is less than w, less than -1, the between values here. And then we got the w greater than -1 values. So for the first one here, I'm going to go ahead and use, so we'll color code this here. Let's use w equals, and I'll make a little space so that we could actually, because there's probably going to be a bit to write here. So I'll use w equals -11. My reasoning is that -11 plus 1 is -10, so then I have a decimal value I could use because it's out of 10. Otherwise, just use a calculator. So 3 minus 9 over -11 plus 1 is -10. And you want to know if that's greater than or equal to 5 minus 1 over, and then -11 plus 1 is still -10. So then when you simplify this, 3 plus 0.9 is 3.9. We want to know, is that greater than or equal to 5 plus 0.1 is 5.1. And this is not true. So not true, which means this interval is out. So not part of our answer. For this one here, I'm going to try to see, is there anything particularly nice? -2 is a nice value to use, because -2 plus 1 is -1, and that will divide evenly. So let's go ahead and use that. So we've got w equals -2, and you got 3 minus 9 over -2 plus 1 is -1. And we want to see, is that greater than or equal to 5 minus 1 over -2 plus 1 is still -1. So now you got 3 plus 9 is 12, and is that greater than or equal to 5 plus 1, which is 6, and that is true. So we could go ahead and color in everything in between on this interval. So this is definitely part of our answer. This is not our answer necessarily, but it's part of our answer. And then the last interval to check, the last one here, I could use w equals 0. 0 is usually a nice number to plug in. And if I use w equals 0, I get 3 minus 9 over 0 plus 1 is 9 over 1, which is just 9. And then I've got 5 minus 1 over 1, so I got 5 minus 1. And then here, 3 minus 9 is -6, and we want to see, is that greater than or equal to 5 minus 1 is 4, and this is not true. A negative number is never greater than or equal to a positive number. So this is not true, which means this interval is out. So it's just this interval here, but to write our answer out formally, we have to include -5 in our solution because it's a root. So we've got -5 is less than or equal to w, which is less than -1. -1 is not included because that's where the rational expression was undefined. So we could write our answer this way, or we could say from -5 to -1, bracket around -5, parenthesis around -1. And the last thing we'll do is look at the graph, and the graph, this segment on the left should be above this graph only between -5 and -1. So let's see. We're going to go to y equals. It's already typed in just to save time, but this is just one way of checking your answer. The testing intervals method, I think, is the quickest way to do these because otherwise you have to set up many cases and that gets messy. So you see the one on the left is the green and the one on the right is the yellow or the gold. And greater than or equal to means this graph is above this graph. So we need the green to be above the gold. And that should only happen between -5 and 1. So if we look, -5 is about here and -1 is over here. So the green should be above the gold only between -5 and -1, which is true. See how the green is above the gold, but to the left of this, the gold is above the green. And after -1, the gold is always above the green. So this definitely checks out. Okay, well, this is going to conclude this video on solving rational inequalities. If you found it helpful, please click the like and subscribe button below. And if you have any requests, leave it in the comments section below. And thank you for watching.